Alright guys, so we are on trigonometry. Okay, so here we're doing trigonometric identities on the unit circle.
So let's just start with some.
So there you go, there's a unit circle, and so this is, you're gonna identify the same thing, right? So you got four acute angles, right? Four kinds of acute angles that was clearly indicated by these four rays, right? These four rays will have four acute angles, but this theta will equal to the theta you have it over here, right? They all have the same theta in terms of against the x-axis, right? Against the x-axis. So what you're gonna do here is you identify the cosine and sine for this point. So right away, cosine is positive and sine is positive as well. Alright, so but when you go over here, you have a negative theta because counterclockwise is positive in terms of theta. You're calculating theta, right? But if you go clockwise, going from here, this is your x-axis, you're starting from here, then you're going this way around, then this is starting from this is going negative theta, right? So here you see the blue theta is negative, right? So if you calculate the cosine, which is the adjacent, over hypotenuse, right? And opposite over hypotenuse, you see the angle is both negative cosine because it's gonna use this angle right here. Alright, so but now you can see the cosine is the same because you got the unit circle. Well, even you don't have the unit circle, the cosine will be the same because you'll have longer hypotenuse, right? But we're here to discuss unit circle. So cosine, you see this and this point, the green point and the blue point they both have the same x, right? The same length going this way, right? The same length going this way. So they both have the same s. So you can conclude that one of the identities of sine and cosine is that cosine theta equals to cosine negative theta. But whereas sine theta equals to negative, right? You're gonna put the negative in the front. Sine theta equals to negative sine negative theta, right? Negative theta. Okay? Remember there's a negative here. Wait. I can't change the color here. What's going on? Okay, I can't change anything here, but alright. So you see the negative here, right? So let's do it again. Sine theta equals to negative sine negative theta. Alright? Negative theta. Because this is positive. The green one, the sine, the green one is positive, but this one, the blue one, is negative. So this is negative. So in order for this to become, the value of it to become the same as this one, you're gonna add a negative sign in the front. Let's go over to here and let's toss it up, right? And let's do some other kinds of angles. Right here you have theta, but it's telling you it's symmetrical, right? It's symmetrical to the green one. So this, you have the same theta, but how do you describe this? How do you describe this? This is pi. How do you describe this angle right here? So if you lay flat, that's pi, right? And you minus the yellow theta, then this angle, the leftover, right, is it's gonna be what? Pi minus theta, right? Pi minus theta, minus this one right here. Okay, so do you have the same cosine? I don't think so. So cosine pi minus theta will have a negative sign, and then you can equal, and that cosine, right? Negative cosine pi minus theta equals to cosine theta, right? Because this is like, this is going this way, which is positive. This is going that way, which is negative. And but sine pi minus theta, you're gonna have the same sine theta, right? You're gonna have the same value as sine theta. So you can conclude that one of the identities, that sine pi minus theta is equal to sine theta. In fact, if you're not good at memorizing stuff, then just draw this in the test, right? Draw the whole graph in the test and then test it out yourself, and then you'll know easily. And it doesn't take like a minute to draw, right? And you have the purple one, which is pi, the whole thing, right? Lay flat is pi, and you plus the theta right here because they are all the same against the x-axis. The theta is all the same. So plus the theta right here. So I'm going to describe this angle from here all the way to here, to this purple point right here. So this ray is represented, the theta of it is represented by pi plus theta, right? Pi plus theta, the angle of it. The angle is pi plus theta, okay? And but you're gonna compare this one to here, right? This one. So pi plus theta. Let's go over here. Pi plus theta compared to here is still the negative, right? You still have to add a negative in the front. So it's gonna be pi. Let me see. Negative cosine pi plus theta, that equals to cosine theta, right? Because you need a negative sign in the front. Because it's negative going this way. Because in the third quadrant, both cosine and sine is negative, right? So what you're gonna do with sine too? Sine, negative sine pi plus theta equals to sine theta, right? Okay, so you got all your identities of sine and cosine if you just draw this graph. Alright, let's think about tangent.
Of theta plus
Okay,
pi.
tangent, you know what? Tangent is sine over cosine. So you're gonna have this in your mind and see if this tangent, at this point, the tangent will be as same as the other ones, right? So let's think about, let's go over here
Negative theta is this.
and think about this point and compare to the yellow, let's compare to the blue point first, the negative theta, right? So the tangent of that, tangent of the green point is sine divided by sine theta divided by cosine theta, right? That's a green point. I'll write a G right here, right? But you know that's gonna be positive, right? And the tangent. Oh, this is a little bit lagged. All right, the tangent of the tangent of the blue point is sine, again, is sine, which is negative, over the cosine, which is positive. So in order for them to be the same, you're gonna add in front of the tangent, you're gonna add a negative sign, right? In order for them to be the same, the values of both sides will be the same. So I'm gonna delete, close this, then open again. Okay, so what was I saying? I was saying tangent of theta, right? You need a minus sign for tangent negative theta in order for them to be the same, right? Okay, and you can, I'm gonna do one more. I left you with the purple one, or yeah, I left you with the purple one to do yourself. I'm gonna do the pi minus theta, and you're gonna think about the tangent, which is sine, right? This one right here over cosine, right? So tangent of pi minus theta is what? Cosine will be negative, so your denominator will be negative, and your numerator will be the same, which is positive. So you still need a negative sign to equal to this. We'll call this a first quadrant one, right? So on your right, you have your first quadrant one here, right? And you need a negative sign for your tangent pi minus theta. Alright guys, so we're doing the identities. So this is like the opposite identities. You're gonna take, so for instance, you have an angle right here, right? It's theta, and you want to form a right angle on top of this yellow line. So it's gonna be here against the white line right here. That's your right angle. So that's right angle plus your theta. So the altogether, this angle will be theta plus pi over 2, because it's 180 over 2, right? It's 90 degree. It's referring to this one, the right angle right here. Okay, so you have from here to here, you have pi theta plus pi over 2. And you're gonna try to compare that one, this dot, to this dot right here. So this dot, how long has it been, in terms of the angle, how long has it been traveled between these two points, right? So from here to here, you traveled the right angle, right? The right angle you traveled. So this whole point, even with this travel to here is the right angle, because you have a right angle against the x and y axis, right? So from this point to here, you have the right angle, which is exactly this line drawn to here, right? That is drawn to here, right? And you have your original point doesn't change, right? So you have these 2 points that has been changed from. You grab these 2 points and travel that the entire pi over 2 angle to over here. These become these 2 points, right? And so you're gonna say, all right, so sine becomes, so let's do sine first. Sine of the new angle, which is theta plus pi over 2, how does that compare to the original theta? That equals to our cosine, right? Because this side equals to this side, right? So that equals to our original cosine theta. And because you move this whole side all the way to here, traveled 90 degree over to here, right? This as well traveled 90 degree to the opposite side, which becomes the adjacent side, right? So the adjacent side of this angle, that equals to our original sine, right? That equals to our original sine. So we're using this side can be put back to here, this side right here, right? So you would say this theta plus pi over 2, you see how it's opposite, right? The opposite. Sine becomes cosine, cosine becomes sine, and the theta plus pi over 2, that is the identity, right? Okay, so let's go over tangent identity.
So you add.
So tangent identity, you have right here, you have a 0.46 radians. We don't know, that could as well be theta, right? You just say this is theta. That is 1 over 2. So the sine is 1, and the cosine here, right? You draw a line down here against the x-axis, and that line is 2, right? 1 over 2. Okay? I mean the ratio of it. Okay? So, but when you go over here, so it is asking you which other angle, right? Which other angles are pi over 2 as well, because you're traveling on this circle, so you're not gonna be different, right? There's not gonna be different. The only difference is gonna be the angle. Okay? So select all that apply. Pi over 2 plus 46, which is theta, right? Pi over 2 plus theta. Is that gonna be the same? No, because we mentioned it before, because that becomes your cosine, right? This cosine becomes your sine, and your cosine becomes your sine, right? So cosine divided by sine is not the same as sine divided by cosine. So the first one will not be applied. The second one, pi minus 0.6, pi minus theta, is this one right here, right? Pi, the flat one, minus the theta, going this way. And this one, is it the same? Well, because the sign is not the same, because this you have a positive sign, of course, but you have a negative cosine for this green bluish line here, right? So that one does not apply either. And how about this one? Pi plus 0.6. Pi is the 180 degree, plus the pi, you have the green line right here. Does that equal to the original in terms of the tangent? Oh well, you have negative cosine, okay, and you have a negative sign. But negative divided by negative, you have positive right there. So in terms of tangent, they are the same. So that one applies. So how about 2 pi over 2 pi minus the theta? 2 pi is this. You draw 2 pi, right? Go over here, and then minus 6. Minus is right here. So you have a minus theta. Is that the same as in terms of tangent? Is that the same? No, because this one is positive and this one is negative, right? Because you have a negative sign. Right? So that one does not apply. And how about the last one? 2 pi travel 2 times, and then theta, right? So you have the same thing. So the last one apply as well. Right? The last one apply as well. So that concludes our trigonometry for the trigonometry identities. We have cosine, sine, and tangents identity. You don't have to do much, you just have to draw it out. You don't have to remember the thing. You just have to mind the signs, right? Positive or negatives in terms of the quadrant, and mind the cosine and sine, which they can switch, right? They can switch with the right angle, right? And then that's it. So hope you have a good day and see you on the next one.